Hello. Today we're going to be multiplying polynomials where a is greater than 1. Okay, where these numbers out front are greater than 1. So 2x times x is 2x squared. 2x times 4 is 8x. 3 times x is 3x. And 3 times 4 is 12. So we have 2x squared plus 11x plus 12. 5x times 7x is 35x squared. 5x times 3 is 15x. Negative 2 times 7x is negative 14x. And negative 2 times a positive 3 is a negative 6. So that's 35x squared plus x minus 6. 3x times x squared is 3x cubed. 3x times negative 3x is negative 9x squared. 3x times 7 is positive 21x. 2 times x squared is 2x squared. 2 times negative 3x is negative 6x. And 2 times 7 is 14. Combine your like terms. You have 3x cubed minus 7x squared, because this is a positive 2, plus 15x plus 14. Factoring polynomials where a is greater than 1, where there has a leading coefficient other than 1, is a little bit more of a challenge, okay? So we can do what we call the simple inside method, where you're multiplying 2 times 5 is 10. Okay, that's a little bit different from what we were doing previous day, because there we were just looking at 5. But anytime you have a coefficient, you have to slip it over here. 2 times 5 is 10, and then 11. So numbers that multiply to give us 10 and add to give us 11. That's going to be 10 and 1. Then we're going to slide this coefficient underneath them and reduce if possible. So 1/2 doesn't reduce, but 10 over 2 reduces to be 5 over 1. Now whenever I write these, this is my coefficient of my factor, the number that goes out in front of my variable. So I'm going to have 1x, or just x, and then this is my constant, so plus 5. Coefficient 2x, constant 1. Try that again. 6 times 3 is 18, and 11. Numbers that multiply to give me 18 and add to give me 11, that'd be a 9 and a 2. Then I'm going to divide by 6. Reduce if possible, that's 1/3. That is 3 over 2. So 3 over 2 represents the factor 2x plus 3. 1/3 represents a factor 3x plus 1. 25x squared minus 10x plus 1. So 25 times 1 is 25. Negative 10. Numbers that multiply to give me 25 and add to give me negative 10 would be a negative 5 and a negative 5. I'm going to divide them by that 25. Reduce if possible, so that gives me negative 1 over 5 and negative 1 over 5. So this would factor to be 5x minus 1 and 5x minus 1. Anytime you have the same factor twice, you can write that as that factor 5x minus 1 squared. 6x squared plus 7x minus 20. So 6 times negative 20 is negative 120. And add to give me 7. Alright, so sometimes it helps to list your factors. So 1 and 120, 2 and 60, 3 and 40, 4 and 30, 5 and 24, 6 and 20. And I know since this is negative and this is positive, they're going to be opposite signs. So I'm really looking at the one that's a difference is 7. 7 is a no. 8, I don't think so. Let's look at 8. Goes into 120. It goes in once. 15. 8 and 15. And the difference between those is 7. So my 8 is going to be negative. My 15 is going to be positive. So that when I add those, that gives me a positive 7. Then I'm going to divide these by 6. reduce if possible. So these are both divisible by 3. That gives me 5 over 2. These are both divisible by 3. That gives me negative 4 over 3. So, sorry. 6. These were just divisible by 2. I apologize. So I have 3x minus 4 and 2x plus 5. And again, if you're ever unsure, you can always multiply these back out and see if you get this right here. You should. Factor sheet 10 is a little bit different. It's got a lot of division on here. Okay, so writing fractions in the simplest form. If you have 20 divided by 84, you're looking at what's the biggest number these are both divisible by, and that's going to be 4. So 20 divided by 4 is 5. 84 divided by 4 is 21. So that's that fraction in simplest form. With exponents, what you're going to do whenever you have exponents is you're going to, and you're dividing, you're going to subtract the exponents and divide the coefficients. This is whenever you are dividing monomials. So this will be x to the 5th. This will be 1 over x to the 5th. You could also write this, you don't have to, but anytime you have a variable in the denominator, you can put it to the negative exponent. So this is the same as x to the negative 5. 18 divided by 3 is 6. X to the 7th divided by x squared is going to be x to the 5th. Then y, and then y to the 4th. Okay, so you could either subtract these. 1 minus 4 is a negative 3 and have y to the negative 3, and then you would need to change it to be y over y to the cubed. You could also say 4 minus 1 is 3, and it just goes on bottom because that's where the bigger exponent is. Then you get to this guy right here. Alright, so we have to factor these polynomials first and then see if they have common factors. So looking at numbers that multiply to give me negative 6 and add to give me a positive 1. Okay, that would be 3 and negative 2. So I could factor the top to be x plus 3 and x minus 2. The bottom, numbers that multiply to give me 12 and add to give me 7, that's 3 and 4. So x plus 3 and x plus 4. My x plus 3's can cancel out, so this is x minus 2 divided by x plus 4, when x is not equal to negative 3. That's just whenever, that's the number that would make me divide by 0 right here. Alright, so just kind of a review with factoring, okay? If there are just two terms, and it's a squared minus b squared, this is called a difference of squares. So if you've got a, you don't have a middle term right here. So if you're looking at this, negative 64, numbers that multiply to give you negative 64 and add to give you 0, that's going to be 8 and negative 8. So this will factor to give me x minus 8 and x plus 8. This always factors to be a minus b and a plus b. Sometimes, like in this case, you have to factor out a GCF, a greatest common factor. These both have a 2n cubed, or sorry, a 2n. So if I take 2n out, I would have 9m squared minus n squared. Then I've got a difference of squares right here. Okay, I could get 9m squared by multiplying 3m times 3m and n squared by n times n. So this would be 2n and then 3m minus n and 3m plus n. Alright, a trinomial, x squared plus bx plus c. You're looking for your factors that add to give you, or sorry, factors of c, of this last number, that add to give you b. Alright, so numbers that multiply to give me negative 42 and add to give me negative 1, that would be a negative 7 and a positive 6. X minus 7, x plus 6. Here, these are all divisible by 2w, so I'm going to factor that out. Or sorry, by 2. not 2w, just 2. So that gives me w squared minus 10w plus 25. Then I'm looking at numbers that multiply to give me 25 and add to give me negative 10. That's going to be a negative 5 and a negative 5. So I'm going to have 2w minus 5. I've got the same factor, so I'm going to have it squared. Then our slip inside. So 30 times 6 is 180. And multiply to give me negative 27. Anytime I have a big number like 180, I'm going to write out my factors. So 1 and 180, 2 and 90, 3 and 60, 4 and, that goes in 4, 45, 5 goes in 3, 36, 6 and 30, Alright, they need to be the same side and same sign because this is positive, and then they're both going to be negative because this is negative. 7 doesn't, 8 does not, 9, yeah, 9 and 20, getting closer, 10 and 18, 11 doesn't go, 12 goes into 180 once, 15, 12 and 15. Yes, if I add those up to give me, they give me 27. They're both negative. That gives me a negative 27. So negative 12 and negative 15. Then I'm going to divide them by 30, reduce if possible. So this is negative 1/2, and that is negative, biggest number that goes in both of those would be 3, 6, negative 2 over 5. So 5x minus 2 and 2x minus 1. Now you may notice right here, 5x times 2x, that's only 10x, okay? Whenever something like that happens, I need to look and see, was there a GCF I could have factored out? And in this case, the answer is yes. These numbers are all divisible by 3. This should have had a 3 out front. So it should be 3 times 5x minus 2 times 2x minus 1. And then 4 terms. We haven't talked about 4 terms, but we will later on next semester. Just a little brief look at this. You look at your first 2 terms and see, what do these have in common? Well, they both have an a squared that can factor out. If I take out an a squared, I'd have 2a minus b, and then I have 10a minus 5b. Those are both divisible by 2. If I take out a 2, I'd have 5a. I apologize. They're both divisible by 5. Then I'd have 2a minus b. Then I have 2a minus b and a 2a minus b. So I'm going to have 2a minus b, and then my other a squared plus 5.